Hello and welcome once again to my channel. In our previous video, we were given a set to find the cardinality, the number of subsets, and the subsets of a given set. Let's start by looking at the answer to that example. The set we were given was B equal to 2, 4, 6, 8, and 10. If you can remember, we said that the cardinality of a set represents the number of elements or members within that set. So when we look at set B, we have 5 elements or 5 members. For that matter, the cardinality of set B will be 5. Then to find the number of subsets, the cardinality becomes an exponent of base 2. So we'll have number of subsets to be equal to 2 power 5 or exponent 5, which will be equal to 32. So we have 32 subsets for set B. By listing the subsets, we'll start with the null set. So we'll have the null set, a set containing 2, 4, 6, 8, 10. Those are the single elements. Then we'll combine double elements. So from the double elements, we'll get 2, 4, 2, 6, 2, 8, 2, 10, 4, 10, 4, 6 rather, 4, 8, 4, 10, 6, 8, 6, 10, 8, 10. These are the double or the 2 elements. Then we'll start by combining 3 elements. So I have 2, 4, 6, 2, 4, 8, 2, 4, 10, 2, 6, 8, 2, 6, 10, 2, 8, 10, 4, 6, 8, 4, 6, 10, 4, 8, 10, 6, 8, 10. And for 4 elements, we have 2, 4, 6, 8, 2, 4, 6, 10, 2, 4, 8, 10, 2, 6, 8, 10, and 4, 6, 8, 10. Then we pick the entire set to conclude the list of the subsets. So these are the subsets, the cardinality, and the number of subsets of set B. To proceed, we are going to look at Venn diagram. What is a Venn diagram? When we talk of a Venn diagram, we are going to represent sets by geometrical diagrams. When we say by geometrical diagrams, usually the set, which is the universal set, is represented by either a rectangle or a square. And other sets or sets are represented by a circle or circles. For example, when we look at the illustrations below, when we have this illustration, the circle here represents set A with its elements 1, 2, 3, 4. Then the rectangle here represents our universal set. So this illustration contains set A and the universal set. So we already said that the universal set is represented by U or Xi. So this is a representation of set A and the universal set. When we have two sets, which is A and set B, we can see that there is no relation between the two circles. So these sets are called disjoint sets, where A intersection B is null. We can also have this illustration where we have set A, set B intersected, but you will see that the portion of A is shaded. This shows or indicates, the shaded portion here indicates elements belonging to set A only. We can illustrate that by saying set A intersection B prime. We can also have elements or an illustration which shows elements belonging to only set B, which we have here, so that the B portion is shaded. So have elements belonging to only set B, and it is illustrated as A prime intersection B. Then we have A intersection B, which represents which is represented by the shaded portion here. Then we have our universal set. Then the last illustration here we will be talking about will be the union of set A and set B, and we can see that the two circles are intersected, or shaded rather, sorry. So we see that the two circles are shaded together with the intersection. So this illustrates A union B. Let's now look at what each of the components or parts of the Venn diagram represents. So we are going to look at practical problems concerning the sets. And with the practical problems concerning the sets, let's first of all look at when the sets are 2. When the sets are 2, representing them on a Venn diagram means we should have two circles, and we have that. We have this as set A, the green circle, and the blue circle represents our set B, whilst the rectangle represents our universal set. We can see that we have 4 components, which are labeled as I, and VENN. Each of these components has what they represent. So let's start by looking at what I represents. The I represents or contains elements which belongs to only set A. So mathematically we represent that as A intersection B prime. Then I contains elements belonging to only set B, which is represented as A prime intersection B. Then I, Roman number 3, represents or contain elements belonging to both set A and set B. We have A intersection B. Then the I VENN, that is Roman number 4, contains elements which neither belongs to set A nor to set B, but they can be found in the universal set. So when we combine the elements of A and B, the elements we have do not belong to the universal set. So representing that mathematically we have A union B all prime. Let's take note. In order to find the number of elements or the number of elements in the universal set, we have to add all all the four components here. So number of u should be equal to I plus I plus I plus I VEN. But in a case where we don't have I VEN, that is, we do not have any element which does not belong to any of the two sets, then the number of u becomes I plus I plus I. This concerns two sets or two sets problems. Now let's look at when we have three sets problems. For three sets problems means we should have three circles in a rectangle. So let's see, we'll have this particular diagram. We have this, we have the red circle which represents our set A, the blue representing our set B, and the green representing our set C, whilst the rectangle here represents our universal set. This one too, we have portions I, VEN, I, and then VEN, I, Roman number 8. So we have 8 portions or 8 sectors or sections. This one too, the I contains elements which belongs to only set A, just like in the two set problems. So this is how we represent that mathematically. A intersection B prime, intersection C prime. Then I also contains elements belonging to set B, and you can represent them mathematically this way. I represents or contains elements belonging to only set C. Then we have I VEN, which contains elements belonging to A intersection B only. They belong to A intersection B only, whilst VEN contains elements which belongs to A intersection C only. Then we also have VEN I, which contains elements which belongs to B at the same time C only. Then we also have VEN I, which contains elements belonging to all the three sets. So in this case we have A intersection B intersection C. Then VEN I contains elements which neither belongs to set A, nor set B, nor set C. It doesn't belong to any of the three sets, and we represent that by the union of the three sets complement. Let's now look at the properties and operations of sets. For the properties and operations of sets, we are going to look at a table, and this particular table indicates the properties. We have the commutative property, we have the associative property, then we have the distributive property. When we relate that to sets, for commutative property we have two sets. If we have A union B and it's the same as B union A, then commutative property is shown here. Or if you have A intersection B equal to B intersection A, again commutative property is shown. Then when we relate it to operations, We can have A plus B to be equal to B plus A, showing commutative property, or A multiplied by B equal to B multiplied by A, showing commutative property. Then for associative property, this contains three sets or three elements. So for example, when we have set A, B, and C, we can have A union B, all union C to be equal to A union B union C. So in this case, you can see that A union B is in bracket here, and here B union C is in bracket here. So when you combine the two elements, first two sets, and combine the last two, combine them with the remaining sets, what you get, if they are the same, then associative property is shown there. Then for intersection, we have A intersection B intersection C, which is equal to A intersection B intersection C. A intersection B in bracket here, B intersection C in bracket here. This shows associative property. Then relating them with the operations, we have A plus B in bracket plus C, and this should be equal to A out plus B plus C in bracket, or A multiplied by B in bracket multiplied by C equal to A multiplied by B multiplied by C in bracket. Then for distributive property, this also contains three elements. We have set A, B, and then C. If you have A intersection in bracket B union C, and this is equal to A intersection B union A intersection C, which we have here, then it shows distributive property. Simply expand the bracket. Or when we have this union first, so we have A union B intersection C, we can have A union B, this union B, and again intersection A union C, then we have that. So when we use multiplication and addition, we have A multiplied by B plus C. This will be A by B plus A by C, which we have here. Or when you look at this one, it has no equivalent in algebra, or it is not always true when we have its equivalence using the operations. Let's now look at examples containing sets. For example, if we have set A to be 2, 4, 6, 8, 10, set B to be 3, 6, 9, 12, and set C to be 1, 3, 5, 7, 9, and 11, and you are asked to find A intersection B, B intersection C, A intersection C, A union B, and A union B union C. We can say that A intersection B will involve elements contained in A at the same time in B. So when we have, these are the sets, so A intersection B will have elements. When we look at this one, we have 2 here, we don't have 2 here. The element we have here, we have 6, they also have 6 here. So for that matter, A intersection B should be equal to 6. The set containing 6. Then A, B intersection C, B here, C there, which elements are common? So 1, we have 3, 3 there. What other elements? We can see 9 here, 9 there. So B intersection C should be equal to 3 and 9. Then to find A intersection C, this A and this C, we have 2, 4, 6, 8, 10. Then we have 1, 3, 5, 7, 9, 11. We can see that there is no element which belongs to A at the same time C. So A intersection C becomes a null set. Then for the last example, we have A union B or union C. First of all, we are going to find A union B, or I-VENN rather, we are finding A union B. A union B means we should combine all the elements, or we should combine the elements belonging to set A and B. So combining them, we'll have A union B to be, we start from the list, so we'll have 2, 3 here, 4, we don't have 5, so we'll continue to 6 here, but you see that 6 is here, 6 is here, but you write it just once. Then we have 8, we have 9, then we have 10, we don't have 11, but we have 12. So this will be the elements of A union B. Then to find A union B or union C, we have A union B already here. Then union C means we should add the elements of C. So A union B union C will be equal to 1. We have 1 here. Then 2, 3, 3 there. We have 4, 5, 6, 7, 8, 9, 10, 11, and then what? 12. This contains elements in A union B and elements in C. So combine them without repeating the elements. So we can represent our results using the Venn diagram. So for the sets equal to that B and then C, we have this representing, you see that it was A intersection B, which has an element 6. So A intersection B will be this. This represents A intersection B. Then we also have this, which contains where the intersection of the B and C will be 3 and 9. So this also represents B intersection C. Then we can also have AC, which had no elements or common elements, so they are disjoint sets. So we have this. So this represents A intersection C, which is equal to 9 of this joint. Let's look at example 2. And this, we are going to consider questions from our final year exams. So we have this particular question, which is a WASI 2017 private objective, which is question number 31, where we are given x to be 1, 3, 5, 2, and y to be 1, 2, 6, 7, 8 are subsets of a universal set, which is U equal to 1, 2, 3, and it continues to 10. Find the number of elements in X union Y prime. Let's see how we solve this. We have set X, Y, then we have set U, the universal. And the universal, we have 1, 2, 3, and it continues up to 10. And when you look at this one, the difference between this and that is 1. This and that, 1. So we keep on adding 1, 1 till we get to 10 to complete the universal set. So from 3, we add 1 to get 4. We add 1 to get 5, 6, 7, 8, 9, 10, 10. Now X union y. Let's find what is in the bracket first. So x union y means we should combine the elements belonging to x and to set y. So we won't combine them. One is here, one is there. So we have 1, 2, we have 3, we have 5, we have 6, 7, and then what? 8. So set x union y should be 1, 2, 3, 5, 6, 7, and 8. Now to find x union y all prime means we should find elements which are in the universal set here but cannot be found in x union y. So 1 is here, 1 is there, 2 here, 2 there, 3 here, 3 there. We don't have 4, 5 here, 5 there, 6 here, 6 there, 7 here, 7 there, 8 here, 8 there. So the elements which are in the universal set but cannot be found in x union y will be 4, 9, and then what? 10. So that gives us x union y all prime to be 4, 9, and 10. Let's look at the next example. So, but they were saying that we should find the number of elements in x union y prime. So the number of elements in x union y prime will be 3. Then looking at the next example, we have p to be equal to x is said that x is less than 5. Q is said that, or is equal to x is said that 2 is less than x, which is also less than 7, and r is equal to all numbers. And these are subsets of the universal set 2, 3, 4, 5, 6, 7, 8, and 9. Now we should find P intersection Q intersection I prime, and also find P union Q or intersection R prime. To find the solution to the questions asked, we have our universal set, which is 2, 3, 4, 5, 6, 7, 8, 9. We also have P, where they said P is said that P is less than 5. P is less than 5. Your elements, since they said they are subsets, or P is a subset of the universal set here, your elements here should contain elements which are here but obeying the range here. So if you are going to start with the sets, the elements of set P, it should also start with the universal here, what the universal set starts with here. So for that matter, listing the elements here, we'll start with 2. P will be equal to 2, 3, 4. We end at 4 since they said s is less than 5. Then for set Q, that 2 is less than x, which is also less than 7, means the number we are to start set Q with should be greater than 2, but it should be less than 7. So greater than 2 comparing to the universal means we should start from 3. So we have Q to be 3, 4, 5, 6, less than 7. Then for set R is a set containing odd numbers. This one, there's no range, but when they since they said odd numbers, we are going to look at odd numbers within the range of the universal set. So this will give us set R to be equal to 3, 5, 7, and then 9. We could have continued, but we'll stop at 9. since the universal set here will be our reference. So for I, we first of all find R prime, elements which can be found in the universal set but cannot be found in R. So the elements of R will be 3, 5, 7, 9. Let's mark them out of the universal. You see that we have 3, 5, 7, 9. So the remaining will be 2, which we have there, 4, which we have here, 6, which we have here, and then 8, which we have there. So that gives us R prime. To now find P intersection Q intersection R prime, we are going to find elements here which can be found in R prime, can be found in P here, and can also be found in Q here. So looking at that, we see that we have 2 here, we don't have 2 here, but we have 2 there. 3 here, 3 here, no 3 here. 4 here, 4 there, and 4 there. So 4 becomes part of P intersection Q intersection R prime. Can you see that? So we are going to find, we can say that a P intersection Q intersection R prime will be equal to 4. Then for Roman number 2, to find P union Q all intersection R prime, we first of all need to find P union Q. And P union Q will be 2, 3, 4, 5, 6. We combine the elements. So I have 2, 3, 4, 5, 6. Then intersection R prime. Which elements can we find here and find in R prime? So I have 2, 2, we have 4, 4, we have 6 here, 6 there. So therefore, P union Q, all intersection R prime with 2, 4, and 6. Thank you for watching. Please subscribe to my channel for the next video. Bye for now.